So now we're going to talk about throwing an object in the air. And so this is still considered free fall because the only thing affecting it is gravity. But since we're throwing it up in the air, it must have an initial velocity that's greater than 0. If it's 0, it's just going to fall straight down. Gravity can't pull it up. So it must have an initial velocity so it can then be pulled back down in this nice parabolic shape, like a parabola. Velocity decreases going up. So here we have some arrows that are representing our velocity. So you notice that speed decreases going up. It hits 0 at the top, and then it increases on the way back down. Anyone who's ever thrown anything in the air has seen this. You have seen this happen where it's going faster, slows down, kind of hovers for a split second, and then comes back down. So decreases going up, 0 at the top, increases going down. This is also a perfectly symmetric, it's perfectly symmetric. And so the final velocity in the end is equal to the initial velocity. It's just negative because it's going down. Again, we're talking about the negative indicating direction. So for example, if this went up at 3 meters per second, it would hit the ground, it'd be 0 up here, and it would hit the ground at negative 3 meters per second, because now it's going in the downward direction. So let's talk about how we would solve problems with this. So you throw a ball straight up in the air. The ball leaves your hand with an upward velocity of 30 meters per second. How high will it go? So its maximum height. How high will it go? These are two ways you might see this asked. So since it's leaving your hand at 30 meters per second, that's your initial velocity. How high it goes is going to be your distance, your d. Technically displacement, but it's going to be d. So let's write those. V naught is equal to 30 meters per second. And then we want to know our d. Again, to solve these, we need 4 variables here, including our unknown. Well, we know gravity is affecting it, so we have g. So g equals negative 9.8 meters per second squared. And we just said that at the highest point, its maximum height, it's going to have a velocity of 0. So going back, you see 0 meters per second at the highest point. So now we've got all 4 variables. We find an equation that has these 4, which is our squared one. It's 2AD, where A is now G. So V is 0. 0 squared is still 0. Our V naught is 30, so 30 squared, plus 2 times negative 9.8 times D. So 0 squared is 0 equals, that'll be 900 minus 19.8 times D. So now we're going to subtract the 900 over. So minus 900 equals negative 19.8 times D. And our last step, divide by negative 19.8. So our final answer, D, is going to be 45, make sure I don't run out of room here, 0.92 meters. So it'll go almost 46 meters in the air. So hang time. Hang time is the total time an object is in the air. So we're looking for T. Again, we know our V naught, which is 30. Sorry, my bad. There we go. So 30 meters per second. We know G. G is negative 9.8 meters per second squared. But now, since it's total time in the air, let's go back to our picture. Now we're dealing with up and down. And so our final velocity is now not 0, but the negative of the initial, because we're coming back to the ground. So our V is now going to be negative 30 meters per second. And we're looking for time. So the equation has those four. V equals V naught plus GT. So V is negative 30 equals 30 minus 9.8 times T, negative 9.8. So first thing we want to do is subtract 30 from both sides. And notice this doesn't cancel out. Negative 30 minus 30 is negative 60 equals negative 9.8 times T. Now we just divide by negative 9.8. And we get a final answer of, our time is 6.12 seconds. So it'll take 6 seconds for it to go up and back down. So last question is, what if it just asks you at any given time? So we still have our initial velocity, still the same, 30 meters per second. We still have g, negative 9.8 meters per second squared. And now we have time, which is 1 second. Here we're looking for how high it's going to go. So we're looking for d. So the equation has those four. d equals v naught t plus 1/2 g2 squared. So we're going to go ahead and plug in our givens. So we're trying to find d. So d is still our unknown. Our v naught is 30. Our time is 1. And then we do plus 1/2 times negative 9.8, which is our g. And then t squared, which is 1 squared. Of course, 1 squared is just 1, right? So we have d equals 30 plus, see, half of negative 9.8 is negative 4.9. And 4.9 times 1 is just 4.9 again. And so our last step is 30 plus a negative 4.9, or 30 minus 4.9, gives us a d of 25.1. So definitely not all the way up to our maximum height, which was 45.92.